Hello class, sorry I couldn't be with you today, but here's your podcast on section 7, apply the fundamental theorem of algebra. On page 379 in your book, you can kind of check it out. It basically deals with the number of solutions a polynomial has. So there's a few corollaries that go along with that, but the main one you really have to know is, for example, number 1, how many solutions does this equation have? I've actually already talked to you guys about this. So this deals with fundamental theorem of algebra. But basically, since this is a third degree, there's going to be 3 solutions. And we know that already. I've told you. So, example number 1, that's all this is. How many solutions does some kind of function have? So there they tell you what the solutions are, but really you only have to tell me this answer. There's 3 solutions. How many zeros does this function have? Same idea, right? The 4th degree, so there are 4 zeros. So, am I going to give you that question on the test? No, probably not. But you need to know that to do the next problems. Alright, example number 2. Find all the zeros of this function right here. Now, just like section 6 where I taught you, look in the calculator, look for some zeros, and use synthetic division, that's what we're going to do here. Okay, now the book takes you a different route and asks you to find all the possible rational zeros and test them and all that kind of stuff, but what we're going to do is we're going to use the calculator to do this one here. So, everybody type that in your calculator. Alright, in your calculator, you see this picture. Now, you notice a few zeros on it. You notice one here, maybe one, could be 2 here. You just don't really know. So, what I do first is I check my table. Look at my table. Notice 2 things. At -1, there's a 0. At 2, there's a 0. So if we go back to here, we can write those down. So, zeros at -1 and +2. And like I showed you last section, section 6, this is the same idea. We're going to use these in synthetic division and keep breaking this function down. Okay, but if I have 2 of them, right now it's x to the 5th, that's only going to bring me to a cubic. So just pay attention to what we do. Here we go. Put in -1 in the box. 1x to the 5th, -4, 4, 10, -13, -14. Use synthetic division. 1, -1, 5, 5, 9, -9. Add them up. 1, -1, -14, and +14. As you notice, -1 is a 0 of the function. Perfect. Now, whatever you get here, you're going to use synthetic again. Only we're going to use this one now, the 2. So we're going to use 2, and I'm not even going to write this out as 1x to the 4th power. We don't need to. We'll just write 1, -5, 9, 1, -14. So we're going to break this one down. 1, 2, -3, multiply, -6, 3, 6, add them up, 7 and 14, and notice 2 is a 0 of this function right here, which is also a 0 of this original function. Now I got this. So this, I'll write it out. X to the 3rd. That's 3x squared plus 3x plus 7. Okay. This is what we call our depressed polynomial. Now what I would do with this, since I don't know any more besides these 2 in the calculator, I type this in my calculator and see if I can find anything. Now if you put this function that you have left over in your calculator, you're going to notice something. Let's go over to there. I put it in my calculator and look at it now, this cubic function. It crosses right here, so I check my table to make sure, and it crosses at -1, 0. There's another 0. So -1 is another 0. And as you notice, -1 was already a 0. right here. Negative 1 was a 0, 2 was a 0, and based off of this right here, negative 1 is also a 0. So put in negative 1 again. Negative 1 with this function. So 1x cubed minus 3x squared, 3x plus 7. Do some work. 1, negative 4, 4, 7, and negative 7. As you notice, negative 1 is a 0 to this function, which is really means negative 1 is a 0 to this big long function up here. Okay, so if you want to, you could put in negative 1 just to kind of, as a placeholder, like, okay, I got 3 zeros so far. I need, 5 total. So I need 2 more zeros. That's going to come from this thing right here. 1x squared minus 4x plus 7. Question is, does this factor or not? You're looking for zeros, so you set it equal to 0. Does it factor? Check it. Factors of 7 that add up to negative 4. So 1 and 7 don't add up to negative 4, and that's all you can do. So the only thing you can do right here is quadratic formula. So negative b, negative 4, so it's positive 4, plus or minus b squared, which is 16, minus 4 times a, which is 1, times c, which is 7, all over 2a, which is 1. So let's do a little bit of work here. 4 plus or minus the discriminant of this, 16 minus 28, which is negative 12, I believe, all over 2. Simplify square root of negative 12. Negative underneath the root, which means there's an I, imaginary number. The original question said find all of the zeros. It didn't say find the real ones, find all of them, including imaginary. So this would simplify to, move this a little bit, 4 plus or minus square root of negative 12 by itself. I don't have any room. Square root of negative 12, square root of negative 1 times the square root of 12, which square root of negative 1 is I. Square root of 12 is square root of 4, square root of 3. So 2I root 3. Now keep in mind that's plus or minus. So it's 4 plus or minus 2I root 3 all over 2, but keep in mind 4 divided by 2 and 2 divided by 2, they simplify again. So this 4 divided by 2 is 2 plus or minus 2I root 3 over 2 is I root 3. These are your other two answers based off of this quadratic right here. So always be ready to use the quadratic formula. I'll just tell you that right away. Okay, so we got 1, 2, 3 zeros up here, and we got our 4 and our 5, which makes a total of 5 total zeros. So 2 plus or minus I root 3. There we go. There's all 5. Okay, I would try doing number 4 by yourself. Number 3, that doesn't take a lot of work. Here's your answers. Number 4, you're going to have to work for it. So here's how you approach this. Put in your calculator. Find as many zeros as you can. Synthetically divide until you come up with a cubic or a quadratic. And then once you get a quadratic, you can use quadratic formula if you need to. So try number 4. Here's your answer to number 4. Check your answer with mine. Notice they wrote the 1 twice. You don't have to do that. But just notice sometimes things repeat. So if you get stuck, like if you got stuck on one of these, like you typed in, you knew you had 1 and you knew you had negative 2. If you took those off of x to the 5th, you'd have a cubic left over. And most people get stuck there. Type that cubic in, like x to the 3rd, blah, 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 and you'll find the other one that repeated. And then you'll be down to a square, like x squared, something, something, something. And then you'll be able to use quadratic formula to get the last 2. I just tell you, that's a pattern. So if you check your homework and stuff, this happens a lot. Okay? So, use your calculator until you get to a quadratic. Then you should be able to do it all by yourself. Okay, next example, example 3. What we have now is they're giving us zeros, and so we have to write the polynomial function. So watch this. Write a polynomial function of least degree, meaning the smallest degree that it has to be, that has rational coefficients. We don't want irrational. A leading coefficient of 1, that's important. And then it tells you the zeros. Okay, sometimes people think that's a 0. No, a leading coefficient of 1, like x cubed, 1x cubed, right? Plus, x squared plus x plus 5. This has a leading coefficient of 1. We don't want it anything else. And here's the important part. 3 and this are our zeros of the function. So if they tell you zeros, remember I told you this earlier, if they tell you zeros, they're really telling you factors. Okay? Or if they tell you factors, really they're telling you zeros, vice versa. So here's the deal. Since 3 is a 0 of the function, x minus 3 is a factor. No, class isn't over. Okay. Next, here's a tricky one. If this thing is a 0, then x minus this thing is a factor. So this problem people have trouble with. Notice it looks weird, right? X minus that is a factor. One more thing you have to know. Sometimes zeros come in pairs. Like you never see just 2 plus root 5 as a 0. You will always see the opposite of that too. 2 plus root 5 and 2 minus root 5. Irrational numbers always come in pairs. Okay, there's a theorem for that in your book. So if I tell you 2 plus root 5 is a 0, then the opposite is true. 2 minus root 5 is also a 0. Alright, another thing to make note of is if I tell you that, this is another question in itself, if I tell you 2i is one of your zeros, like I do up here, I told you this is a 0. If 2i is a 0, then you have to know that these things always come in pairs too. So therefore, negative 2i also has to be a 0. Okay? So if 2i is a 0, then negative 2i is a 0. If square root of 3 is a 0, then you have to know irrational numbers come in pairs. Negative square root of 3 also has to be a 0. So they're not always going to tell you every single little 0 up above. This is the stuff you have to know to do it. Okay? So here's what we do. X minus r, well, the first one is 3. X minus 3 is a factor. And x minus, this is 2 plus root 5, is another factor. So x minus this. And then based off of this theorem over here, we have to say x minus, instead of 2 plus root 5, the opposite of that has to be true. 2 minus root 5 is also a 0 of whatever this function is. Remember, they come in pairs. Okay? So you have to be able to multiply these three things together. And that's the tricky part. So whenever you're given pairs, like this one and this one, let's multiply just these two things together first. Watch what happens. X minus, I'm going to just distribute this minus 2 minus root 5. And then I'm going to distribute this minus sign. This becomes x minus 2. And then minus a minus becomes a plus root 5. Now I want you to see something here. X minus 2 minus root 5, x minus 2 plus root 5. You see anything that you've ever noticed before? This is like a minus b, a plus b. Okay? A minus b and a plus b. So, if you want to, I guess you can multiply, x times all these, 2 times all these, negative 5 times all these. I think that would work, but the way we're going to do it is we're going to kind of just put some parentheses around here, and this is like a minus b, a plus b. If you have a minus b times a plus b, that's the same thing as, you guys should know, a squared minus b squared. And this is the tricky part for people. So if you use this formula, since it's in this, in this way, we take a. So you got to figure out, okay, what's my a, what's my b, and then square those. Here's my a, x minus 2. So what I'm going to do is x minus 2, square it, a, square it, minus my b. What's my b? Square root of 5 is my b. So square root of 5, square it. All I have to do now is simplify. This is x squared minus 2x, so minus 4x, and then 2 squared is plus 4. This becomes minus square root of 5 squared is just 5. Simplify one more step. These two, x squared minus 4x plus 4 minus 5 become minus 1. All of that, if you multiply these two things together, you get this thing right here. Okay? Took a little bit of work to get there, but that's the way it is. And lastly, we still have, we forget this sometimes, x minus 3 out front here. We need to multiply this to all these. But I waited to the end. I multiplied these two, got this. So I'm going to multiply x minus 3 to this thing to get my final answer. X times x squared, x cubed, x times minus 4x is minus 4x squared. X times minus 1 is minus x. Last one. Minus 3 times all these is minus 3x squared. Minus 3 times minus 4 plus 12x. Minus 3 times minus 1 plus 3. Almost done. Last step. Simplify all this. X cubed. Put the squares together. That's minus 7x squared. Put the x's together. That's plus 11x. And then plus 3 on the end. So f of x equals this. You just found the function that has the least degree of 3. Has to be 3, and there's 1, 2, 3 factors. That's the least it could be, is a 3. I could make another function up here that had more factors, but this is the least one. That has rational coefficients. Look at all the coefficients here. They're all rational. And a leading coefficient of 1. Notice my leading coefficient is 1. So, you just have to understand all the zeros. Take a 0 and make a factor out of it. 3 is a 0, make a factor, x minus 3. This is a 0, make a factor out of it, x minus that 0. Since that always happens in pairs, we have to do the other factor, x minus the other one, 2 minus root 5. And then after that, this is the tricky part. Please star this problem. I'm going to give it to you. Okay? Check it out. Do a couple of those. Alright, let's look at some examples of that example number 3 about writing a polynomial function that has, they tell you all the zeros. So I wrote down 3 examples. Number 1, if I told you that these were the zeros of the function, all you have to do is say, okay, if that's a 0, then x minus this is a factor. So that becomes x plus 1 is a factor. And you say, okay, 2i is a 0, so that means x minus 2i is a factor. But if you remember, imaginary numbers always come in pairs. So if 2i is a solution, then negative 2i is also a solution based on that theorem. So you have to write x minus negative 2i, which becomes x plus 2i. Now you have to do the hard work, which is multiply all these 3 things together. Always do this stuff first. X minus 2x plus 2i, that's not bad. Difference of squares. So multiply all those through and get an answer. I just want to look at the setup here. Number 2, once again, negative 2. That doesn't mean positive 2 has to be a solution. That's okay. So x plus 2 is a factor then. Square root of 11, so that means x minus root 11 is a factor. But once again, rational or irrational numbers always come in pairs. So if root 11 is one answer, then negative root 11 is also an answer. They don't have to tell you that. So this becomes x plus root 11. as another factor. Then you see the last one here. 2 plus I is a 0. So that means x minus parentheses 2 plus I. But then you have 2 minus I is also a 0. So therefore x minus 2 minus I is the setup here. Alright, so if you look at that example 2, you'd have to multiply these together first, get an answer, multiply these together, get an answer, and then multiply whatever you got there together, plus then multiply x plus 2 to your final answer there. I'm not going to do that, I don't have the space, but we just did that, something similar to that, just a moment ago. So make sure you go back to that, how to do something like this. That's the key, it's the hard part. Let's just look at the setup for number 3, and then I'll show you the answer. So you got 3 is a 0, so x minus 3 is a factor. You got 4 plus 2i, which means x minus 4 plus 2i is a factor. But remember, they come in pairs, so the other 0 that's not mentioned should be 4 minus 2i. And then if you look here, 1 plus root 7 is a 0, which means 1 minus root 7 is also a 0. So look, 1, 2, 3, 4, 5 zeros, which would mean this would be a 5th degree, like x to the 5th. So let's finish the setup. So x minus 4 minus 2i, so that's the other 0. So 4 minus 2i. And then x minus this 0. So x minus 1 plus root 7. And then since that's a 0, the other one is 2, so x minus 1 minus root 7. Now, this one's going to be fairly complicated. It's going to take you a while just to get this answer. It's going to take you a little while just to get this answer. Then multiply those two things together, and then multiply that to x minus 3. So I want you to take a few minutes, try to get that answer, pause the video, and I'll write this answer down. Okay. The answer to this question, let's see, is 31 x to the 5th minus 13x to the 4th plus 60x cubed minus 82x squared minus 144x plus 360. There is your polynomial function of least degree. Leading coefficient is 1. It's your final answer. Alright.